Right now, as you read these words, something is happening 5.7 billion light years away that should not be happening. A pit in the fabric of reality, a wound in space-time so vast that light itself needs 3 full weeks just to crawl from one side of it to the other, has opened its mouth and started to feed. It had been sleeping. For hundreds of millions of years, maybe longer, it sat in the dark, silent, patient, indifferent. And then, recently, by some cosmic measure of recently, it stirred. It began to swallow. And the galaxy around it, an entire city of stars caught in its gravity, is now burning through its own gas at a rate that makes our Milky Way look like a dying candle. This thing has a name, though it barely deserves one, because names are for objects, and this is not really an object anymore. It is called Phoenix A, and it may be the single largest black hole humanity has ever found. Not the biggest star, not the biggest planet, the biggest single thing of any kind, anywhere in the known universe. And the part that should keep you awake tonight is not its size. It is that we almost missed it. We found it by accident. We found it because it left a faint smudge on the afterglow of the Big Bang, a tiny distortion in the oldest light there is. And once we looked closer, we realized we had been staring at a monster the whole time. Let me try to make you feel how big this is, because numbers alone will not do it. They never do. Our sun, that fierce, blinding disk that warms your skin in summer and keeps every living thing on this planet alive, weighs 1 solar mass. Obviously, that is the unit. The black hole sitting at the heart of our own galaxy, the one our entire spiral of 200 billion stars circles around like a slow, majestic carousel, weighs about 4 million solar masses. That sounds enormous, and it is. If you crushed our sun down into a black hole, its event horizon would be smaller than a city block. The one at the center of the Milky Way would fit inside the orbit of Mercury. Big, truly big, the kind of big that makes you feel small in a comforting way. The way standing at the rim of the Grand Canyon makes you feel small. Phoenix A is 100 billion solar masses, maybe more. Read that again, 100 billion. That is 25,000 times the mass of the black hole at the center of our galaxy. Take everything our Milky Way has ever made, every star, every dust cloud, every comet and rogue planet and dying ember, gather it all up, and Phoenix A is still heavier than that, hundreds of times over, in a single point, not a galaxy, a point, or rather a region, because at this scale, the words start to break down. Picture, for a moment, our solar system. The sun in the center, Mercury racing around it, then Venus, then Earth, then Mars, then the asteroid belt, then the gas giants, then Pluto out at the cold, dark edge, 4 billion miles away. From the Sun to Pluto is a distance so vast that the fastest spacecraft we have ever built took almost a decade to cross it. Now imagine Phoenix A laid across that same scale. Its event horizon, the boundary past which nothing can ever return, not light, not information, not even the memory of having existed, would stretch from the Sun out past Pluto and keep going and keep going and keep going. About 100 times further, the diameter of this single black hole is roughly 370 billion miles. A photon, the fastest messenger in the universe, traveling at 300,000 kilometers every second, would need 21 days to cross it, 3 weeks. If you fired a beam of light at one edge of Phoenix A and waited, by the time it emerged on the other side, you could have flown around the Earth, taken a vacation, written a novel, and forgotten about it. A commercial airliner cruising at 500 miles per hour would need over 70,000 years to make the same trip. The entire history of human civilization, from the first painted caves to the rockets we send to Mars, would not be enough time for that plane to cross from one side of this single shadow to the other. And it is not even a hole, not in the way you are picturing. There is no edge you would crash into, no wall, no rim. The event horizon is just a mathematical surface, a place where the geometry of space tilts so steeply inward that every possible future points down. If you somehow drifted toward it in a small ship, you would feel nothing as you crossed. No bump, no tearing, no warning. For a black hole this large, the tidal forces at the horizon are gentle, gentler than the gravity holding you in your chair right now. You could float across that line and never know you had. Your radio could still send signals back. for a while. You could still see the stars behind you, although they would be slowly gathering into a smaller and smaller circle of light. And then, hours later, days later, somewhere deep inside that vast, quiet territory, the geometry would close in and the universe would simply forget that you had ever been part of it. That is what makes ultramassive black holes feel less like predators and more like empires. They do not bite, they annex. They do not consume, they include. So how does the universe build something like this? That is where the story turns strange, because the honest answer, the answer that astronomers actually whisper to each other at conferences, is that we are not sure it should be possible. Let me explain what I mean. The standard recipe for growing a supermassive black hole goes something like this. You start with a dead star, perhaps 100 times the mass of our sun, that collapses into a stellar black hole. Then it eats. Gas falls in, the black hole grows. It collides with other black holes when their host galaxies merge, the way two drops of water on a windshield slide together into one larger drop. Over billions of years, with patience and a steady diet, you build up to something with a few million, maybe a few billion solar masses. The math just barely works. For Phoenix A, the math does not work, not even close. The universe is 13.8 billion years old. To assemble 100 billion solar masses through ordinary feeding, you would need a black hole to gorge itself at nearly the maximum theoretical rate, continuously, without burping or choking or pausing, for almost the entire age of existence. And real black holes do not behave like that. They are messy eaters. When too much matter piles up around them, the heat and radiation from the infalling material actually pushes the rest of the meal away. Imagine trying to eat soup so hot that the steam from it shoves the spoon out of your hand every time you bring it close to your mouth. That is what feeding looks like for a black hole at maximum rate. It throttles itself. It takes breaks. It naps. So either Phoenix A is much older than it should be, which is impossible, or it grew through some process we do not fully understand. One leading idea is that the seeds of these ultramassive monsters were never stars at all. In the chaos of the very early universe, when the cosmos was hot and dense and frantic, enormous clouds of primordial gas may have collapsed directly into black holes without ever igniting as stars. Skip the candle, start with the furnace. These so-called direct collapse seeds could have begun life already tens or hundreds of thousands of solar masses heavy, giving them a tremendous head start. Another possibility is that when entire galaxy clusters collided in the deep past, their central black holes spiraled together and merged, like raindrops pooling at the bottom of a window pane, accumulating into something the original recipe could never have made alone. Either way, the textbook is wrong, or at least incomplete. By the rules we thought we understood, Phoenix A has no right to be here, and yet, there it is, hanging in the sky, daring us to revise our story. Now here is where the tale gets even stranger, because Phoenix A is not just unusually large, it is unusually awake. To understand why that matters, you have to understand the neighborhood it lives in. Phoenix A sits at the heart of a galaxy cluster, an enormous swarm of galaxies bound together by gravity. Not a galaxy, a cluster of them. Hundreds of galaxies, possibly more, all swimming through a shared atmosphere of incredibly hot gas. We are not talking about gas like the air you breathe. We are talking about plasma heated to tens of millions of degrees, so hot that its atoms have been stripped of their electrons, so bright in X-rays that it outshines everything else in its corner of the sky. The total mass of the Phoenix cluster, galaxies and gas and dark matter all together, is around 2 quadrillion times the mass of our Sun. It is one of the most massive single structures we have ever identified. In most clusters like this, there is a delicate balance happening, an invisible thermostat that keeps everything stable. The hot gas between the galaxies is constantly trying to cool down, the way a pot of boiling water cools when you take it off the stove. As it cools, it should sink toward the cluster's center, gathering, condensing, and eventually forming new stars at staggering rates. That is what the physics predicts. That is what the equations demand. And yet, in cluster after cluster, it does not happen. Why? Because the supermassive black hole at the center acts like a furnace with a temper. Every time too much gas pools nearby, the black hole feeds, and as it feeds, it launches enormous jets of energy outward, reheating the surrounding plasma and chasing it back into the larger volume. Cool gas falls, the black hole burps, the gas gets cooked again, and the cycle holds. once, the thermostat works. Star formation stays modest. The cluster settles into a kind of equilibrium that can last for billions of years. In the Phoenix cluster, the thermostat is broken. The gas is cooling faster than the black hole can stop it, and the result is one of the most extraordinary spectacles in the known universe. The central galaxy of the Phoenix cluster is currently forming new stars at a rate of around 700 to 1,000 solar masses every year. To put that in perspective, our entire Milky Way galaxy, the great spiral that contains everything you can see on a dark night and much more besides, forms about 1 solar mass of new stars per year. 1. Phoenix is doing it nearly 1,000 times faster. Picture standing on a planet inside that galaxy. Every few decades, an entirely new bright star would ignite somewhere in your sky. Within a single human lifetime, the constellations would have to be redrawn. Within a single generation, the night would look different. You would live in a galaxy where the sky itself is restless, where stars are being born so quickly that the ceiling of the world is in constant revision. And in the middle of all that newborn fury, swallowing as fast as it can, sits Phoenix A. Try to imagine this for a moment. Close your eyes if you can, or just let your mind drift. Picture a galaxy at the center of a cluster, glowing with the heat of hundreds of millions of infant stars, all packed into a region not much bigger than our own. Around it, X-rays pouring out of cooling plasma, painting the surrounding space in colors no human eye will ever see. 2 jets of high-energy particles screaming out from the very center, perpendicular to everything, traveling at nearly the speed of light, carving cavities through the gas the size of small galaxies. And at the absolute heart of it, invisible but unmistakable in its effects, a region of darkness larger than our solar system by a factor of 100. Not gleaming, not glowing, not even truly dark, because the matter falling into it superheats to incandescent white in the final moments before it disappears. Just a place where, in any meaningful sense, the universe ends. Now here is the part that should stop you in your tracks. The light that we are seeing from the Phoenix cluster right now, the light that our telescopes are catching tonight and turning into the images and data that scientists pore over, that light started its journey 5.7 billion years ago. 5.7 billion. When it left Phoenix A, Earth did not exist. The sun had not yet formed. There was no solar system. There was a swirling cloud of gas and dust where our planet would eventually condense, and that cloud had not even begun to collapse. The light that is reaching us right now is older than the ground beneath your feet. It is older than every rock you have ever held, every river that has ever flowed, every breath any creature has ever taken on this world. It is older than life. By the time it arrived, an entire planet had formed and cooled. An atmosphere had grown, oceans had filled, life had appeared, evolved, climbed out of the water, learned to walk, learned to think, built civilizations, built telescopes, and pointed them at the sky. And the light just kept coming, indifferent, ancient, carrying its message about the monster. That is one of the things astronomy does to you if you let it. It teaches you that the past and the present are not as separate as we pretend. The sky is not a snapshot. It is a layered archive of moments from across the entire history of the universe, all arriving at your eye at once. The moon you see is 1¼ seconds old. The sun you feel is 8 minutes old. The nearest star is 4 years old. The Andromeda galaxy is 2.5 million years old. Phoenix A, as you see it, is 5.5 billion years old. And yet it is happening to you, in your present, on the back of your retina, in this very moment. The question scientists keep asking is why Phoenix A is awake at all. Most ultramassive black holes are not. Once a black hole grows to truly extreme size, it tends to fall silent. Its galaxy has been stripped of cold gas. Its appetite has nothing left to satisfy. The biggest tend to be the sleepiest, like elderly giants who have eaten enough for 10 lifetimes, and now drift through eternity without stirring. Phoenix breaks this pattern. Phoenix is hungry, and the leading explanations have to do with the cluster's strange geometry. It is unusually compact for its enormous mass, with most of its matter packed into a small central region, which creates an unusually steep gravitational well. Imagine the difference between rolling a marble down a gentle hillside and rolling it into a funnel. The cluster is a funnel. Gas pours toward the center, faster than the black hole's jets can push it back out. There is also the cluster's history. Most massive clusters get violently shaken by mergers with other clusters, like two cities crashing into one another, mixing their populations and stirring up everything that was settled. Each merger heats the gas, disrupts the cooling flow, and resets the thermostat. The Phoenix cluster appears to have avoided major mergers for billions of years. It has been left alone, and so its gas has settled and cooled and begun the slow, inevitable descent toward the center. And Phoenix A is now caught in something it cannot regulate. A monster that woke up to find a meal too large to handle, too large to chase away, too large to outrun. What makes this so haunting is that what we are watching in Phoenix may be a live performance of an ancient act. In the early universe, when the first supermassive black holes were assembling themselves out of the primordial chaos, this kind of runaway feeding may have been common. The galaxies of that era may have been wild, blazing with new stars, devouring their gas, burning bright for a cosmic moment before settling into the quieter forms we see around us today. Most of that drama is over. The universe has aged into something calmer, something more orderly, like a room after the party has ended. But Phoenix did not get the message. Phoenix is still throwing the party. We are looking through our telescopes at a piece of the deep past playing out in real time, a fossil behavior that has somehow survived into the present, a glimpse of the universe as it was when it was young and reckless and unfinished. I want you to try something now, just a small thing, an experiment of imagination. Set this aside for a moment and look at your hand. Really look at it. The wrinkles in your knuckles, the faint blue lines of your veins, the small constellations of moles or freckles or scars you have collected over the years. Everything in that hand, every atom of carbon and oxygen and iron and calcium was forged inside a star. Not metaphorically, literally. The heavier elements that make up your body could not have existed in the early universe. They had to be cooked in stellar cores under pressures and temperatures so extreme that protons fused together against their will, and then those stars had to die, scattering their guts across space, and that wreckage had to gather into new clouds, and those clouds had to collapse into new stars and planets, and one of those planets had to develop the right chemistry for life. You are made of star debris, and every star that contributed to you, every supernova that seeded your atoms, every cloud that gave them a home, is part of a chain of events that has been running uninterrupted since the Big Bang. Now hold that thought, and remember that while all of that was happening, every step of it, Phoenix A was already there. It was there before your atoms were forged. It was there before the stars that forged them ever ignited. It will be there long after you and I and everyone we have ever known and every memory of us is gone. It will outlast the sun. It will outlast our galaxy. Almost certainly, it will outlast the very concept of a galaxy, as the universe ages and the structures we love dissolve into ever thinner expanses. And in all that vast, unfathomable time, the thing that astonishes me is not that Phoenix A is large, it is that it is patient. Something so colossal can be so still. Something so hungry can wait so long between meals. The universe contains entities whose existence operates on a timescale so far beyond ours that we are not even a footnote to them. We are not even noise. And yet here we are, fragile, brief, ephemeral, with eyes that can detect single photons and minds that can hold the concept of 100 billion solar masses looking back. That is the part that gives me chills every time. Not the size, not the math, but the contact. The fact that a creature like you, sitting in a chair, on a planet, on the inner edge of a spiral arm, in an ordinary galaxy, in an ordinary cluster, can look across 5.5 billion years of empty space and recognize, accurately, what is on the other side. That is one of the most extraordinary things this species has ever done. Most of the universe will never know it is being observed. Phoenix A does not know. The cluster does not know. The hot plasma falling forever into that endless dark does not know. We are watching, and almost nothing else in the cosmos is watching with us. The strangest implication of all this is what Phoenix A suggests about everything else. We found it because of an accident, because its host cluster happens to have a broken thermostat, which makes the system glow extravagantly in X-rays and stand out in our surveys. The black hole itself, sitting at the center, is only visible to us because it is currently feeding. But what about the ones that are not? What about the ultramassive black holes lurking in galaxies and clusters that long ago exhausted their fuel and fell silent? Those would be invisible, or nearly so. They would not blaze in X-rays. They would not host firestorms of new stars. They would simply sit in the dark, doing nothing at all, the way Phoenix A did for hundreds of millions of years before it stirred. The universe could be salted with these things, dozens of them, hundreds, thousands. We have no reliable way to count, because we mostly notice black holes when they make trouble, and the dormant ones make none. Some theorists have started using a new word, stupendously large black holes, for objects pushing toward or beyond 100 billion solar masses. The category is awkward because it bumps up against the upper limits of what general relativity, our best theory of gravity, comfortably allows. We do not know if there are bigger ones out there. We do not know how the truly largest formed. We do not know what role they play in the long, slow evolution of the cosmos, in the eventual fate of galaxies and clusters, and even the empty spaces between them. But we know they are real, and we know Phoenix A is one of them, and we know that for most of human history, we did not even suspect such things could exist. This, I think, is the great gift of astronomy. Every generation of humans thought it had a handle on the size of reality. The ancients thought the sky was a dome. The Greeks thought the Earth was the center, the cosmos a series of crystal spheres around it. The Renaissance pushed the sun to the middle, and that felt monumentally humbling for a while. Then we learned the sun was just one star among many in a galaxy, and the galaxy was just one among many in a universe, and the universe was older and larger than anyone had dared imagine. Each step outward made us smaller, and each step taught us that what we had thought was big was actually a footnote. Phoenix A is the latest footnote, a region of space large enough that light takes weeks to cross it, a presence heavy enough to hold together a city of galaxies bigger than anything in our local sky. And it is just one thing in a universe full of structures we have only just begun to map. When I think about Phoenix A late at night, I do not feel afraid. I have been asked that more than once. Does it not terrify you that there are things out there so enormous, so indifferent, so patient? And I always have to pause because no, it does not. It moves me. There is a difference between fear and awe, and we sometimes confuse them because both of them make the small bones in our chest vibrate in the same way. Fear says, I am in danger. Awe says, I am in the presence of something larger than I can hold. Phoenix A is not coming for us. It cannot. 5.7 billion light years is a moat the universe itself has dug between us and that ancient throne. Phoenix A does not even know we exist. It will never know. By the time the light from our small civilization could possibly reach it, Earth will be long gone, and the sun will be a cooling cinder, and the very arrangement of galaxies in this part of the universe will have shifted into something unrecognizable. We are utterly safe from it. What we are not safe from is the wonder of it, and I think that is the right place to land, because there is a temptation when you stand at the edge of something this large to feel diminished. To think, well, if there are objects out there 100 billion times the mass of the sun, what does my life amount to? What does anything I do matter? But I would argue the opposite. The fact that you can know this, the fact that the matter inside your skull can configure itself into an understanding of Phoenix A, is one of the most extraordinary facts about Phoenix A. Most of the universe has no idea about itself. Most of the universe is matter that has never been more than matter. You are matter that has woken up. You are atoms that have learned to look, and those atoms, gathered into the shape of you, are now contemplating a black hole almost 6 billion light years away and grasping it, however imperfectly, however briefly. That is not small. That is one of the rarest things in the cosmos. Somewhere out there, right now, as your heart beats and your lungs fill and the blood moves quietly through your body, the light from Phoenix A is still arriving. Photons that left when our world was nothing but a cloud are still falling onto our telescopes, carrying their old, faithful message about a hungry giant in a distant cluster. They will keep arriving tomorrow. They will keep arriving next year. They will keep arriving for as long as there is anyone on this planet to catch them. And every one of those photons is a thread connecting your present to a moment in the deep past. A moment when the Earth did not yet exist. A moment that has been traveling toward you, specifically for almost 6 billion years, just to be intercepted by your eye. That is not a hole in the universe. That is a doorway, a way of standing in your kitchen or your bedroom or wherever you happen to be and and reaching across more time than your species has existed and touching something, briefly, carefully, with understanding, and then going about your day with the small, secret knowledge that you live in a cosmos large enough to contain a Phoenix A and small enough that you can hold the thought of it in your mind without spilling. There is a hole in the universe, yes, but there is also, in you, a kind of mirror that can reflect it, a consciousness that can stand at the edge of all that ancient dark and not flinch, but lean closer and ask more questions and want to understand. That is the real story here, not the monster, the fact that we found it, the fact that we keep finding things like it, the fact that every generation of humans has stood under the same sky and asked the same wordless question and gotten back a little more of an answer than the one before, and the answers keep getting larger, and we keep getting bigger by being able to hold them. Phoenix A is awake, and so, in our small, bright way, are we. Of all the strange and beautiful coincidences in the long story of the cosmos, that one might be the strangest and the most beautiful of all.